I am Ashutosh, and I work with the different kinds of robots. So today I'm going to mostly focus on cars that I recently started working on. They are a particular type of robot. These manipulator arms that Anka showed that do things in our houses and offices that I worked for last 5-10 years. And more recently that Ken alluded to house. A house is a robot. I'll get to it for a second. So this is just a video that shows that we have been recently doing. And what you're seeing here is that a car is driving, and a lot of accidents in the US happen because we cannot understand humans.
As
Cars
drivers,
are driving.
We trust ourselves to make the right decisions. But we rarely detect disaster until it's too late.
So what we do is we actually look at driver inside the car. So a lot of work has been done in making autonomous cars that look at outside world and figure out what is happening. But to understand the humans is very hard task because robots and humans often work together.
Anticipates your actions before they occur.
So we use an algorithm that continuously observes these humans and figures out, hey, this person is trying to turn right, and there is a bike, so it's a good time to give an alert. And we have been testing it over thousands of miles of driving data in California and Nevada area. There's this another robot that I worked with, which is this manipulator robot. And the idea here was that if a robot is inside our homes, it has to interact with people and do tasks for us. This is just one of the many sample tasks we did. And here the robot is actually trying to make coffee by reading a manual, and it has never seen this barista machine before. So what was shown to you, it is actually looking at previous examples, which included a urinal. Don't ask me why. But robot is just learning from random things. It has seen a lot of data through our knowledge base. It has been transferring that information. So it has learned this representation of how you can manipulate things, how to read manuals, how to look at point cloud and images, and perform some of these tasks. And it's, by the way, a speed of video about 3x or 5x. Or maybe even more at this point in time. And it's trying to make us barista. Our robot can today operate many appliances that it has not seen before by transferring knowledge that it has learned. Let me give you a little bit of insight on how does it exactly work. So what we have here is that whenever a robot, such as a car or a robot like this, goes around to do some particular task, it has to first see the environment, which is what Jitendra referred to, like it sees images of different items and so on. It has to relate what it is seeing to maybe some other tasks, such as language. So for example, it is technically not reading from this book. It's reading from an online recipe. But the recipe is online. There's a lot of knowledge online. There are thousands of WikiHow documents, thousands of YouTube videos. So in my projects, we have been parsing those videos. And whenever you see an instruction like turn down the lever to open the tap or whatever this thing is, it correlates the two. So it makes a representation of what it is seeing. It makes a representation of the language. It also makes a representation of the robot arm. So there's a lot of kinematic stuff that goes around, which we go up. And then it makes a joint representation of these different modalities. So this is one of the major advances we have done, in which by using different machine learning techniques, including deep learning to learn these representations, we have been able to correlate very different modalities, such as language, motion trajectories, images, point clouds, and even haptic data recently. So the way it works is that we take these perceptual observations, such as this. We take the language observations, we parse them into some representation. We take the motion trajectories, and we all map them to the same space. So this is part of this RoboBrain project, which collects a lot of information from WikiHow, YouTube, different robot demonstrations across Cornell, Stanford, and Brown. And it maps all these learned symbols, such as particular motion, that, OK, pull the lever, which is a text, which is an observation, which is a motion, all into the same space. And this has allowed us to do a lot of things, ranging from grasping. So we have learned features by using deep learning, and it's a completely unsupervised algorithm that can look at the data and figure out, hey, whenever something looks like this is a handle, which a robot can grab. It means it can grab. We have been able to cut food items. So a lot of haptic information is also mapped down to the same space, and so on. So very recently, what I have been thinking about is that robots are only one way to interact with the world, just like cars. But another place where we interact with more than 12 hours a day, sometimes more, sometimes less, is our homes. And our homes are actually still in 20th century or 19th century. The only thing that changed in the home since 19th century is that we have electrical lamps instead of gas lamps. That's it. And we are talking about deep learning and robots and fancy automations, and these houses have done nothing so far. So I cannot talk much about it, but very soon next year, you will hear about a lot of things that homes can do for you. And I really believe in doing this because not just for entertainment and convenience, but I also work with elderly living in these homes and through the robots earlier. And just to do a simple task like opening a light switch is so much effort for some of us. Robots can help doing that, but homes can also help doing that. So I look forward to making house a robot. Thank you.